I want to show you some application of line integral and potential and conservative vector field in physics in the case of an ideal gas. And we will use the state equation of the ideal gas. Because some people don't like formulas to fall from heaven, let me give some very simple, very simplified reasoning where does this state equation comes from. Here P stands for pressure, V is the volume, N is the number of moles, how much quantity we have, R is the universal gas constant, what's this value, and T is the absolute temperature. So to derive this state equation, consider a box with gas. And the molecules bounce up and down, and as they hit the wall, they apply some small pressure. But there are many of them, and we have some pressure on the walls, and we want to find some formula for this pressure. Before we go further, let's denote this line B. So the volume will be B cubed, and the area of the side will be B squared. If we have a molecule traveling with velocity v, then it somewhere in the middle of the box, then it takes time t to bounce to the wall and go back, and this time will be b half to the right, b half to the left, so b divided by the velocity v. And the force from one molecule will be the mass of the molecule times the acceleration. Acceleration is change of the velocity over some time t. And if it travels with velocity v to the right and then v to the left, then the change of the velocity is 2v, and the time is b divided by v, which is 2mv squared divided by b. So this is the force from one molecule, and if we have capital N molecules, then the pressure will be the total force, and if we have some molecules going up, some going down, some going to the left, to the right, to the front, to the back, then N over 6 of the molecules will be traveling to the right. And the force of one molecule divided by the area of the side, which is m divided by 6. F1 is 2mv squared divided by b squared means divided by b cubed. But b cubed is volume, and if we multiply by the volume, we have that P times V is 1/3 mv squared. But if we consider the kinetic energy of one molecule, 1/2 mv squared, then if we want 1/2, we must multiply by 2, and we have 2/3 n kinetic energy of one molecule. So number of molecules times the kinetic energy of one of them is the total energy, and this is sometimes denoted by U, the internal energy of the system consisting of these gas molecules. Well, and the measure of the internal energy is the absolute temperature, and this is proportional to the temperature, proportional to the number of molecules or to the number of moles, and the constant of proportionality is this universal gas constant R. So we have the state equation of the ideal gas, and we will use this to show you some consideration how the line integral is interesting in physics and physical chemistry.